Have you ever thought in this way while you are going to school or the office daily? How many things you observe on the way? You may see a roadblock due to construction works for the metro going on. So many things you see, hear, and feel. Your favorite bakery, which you might want to visit later. Unsafe road due to manhole or open drainage. Numbers of cars and scooters at the crossroad, or a railway crossing, or a number of bridges coming across your route. But what if I tell you that all this information is vital for town planners, engineers, and people like us? And how useful it is if we have all this information in a spreadsheet, like a number of routes available to reach your school or office, peak traffic hours, and so on. So, what wonders it can do if all this information is on the map? Now you can decide the shortest route or you can avoid traffic to reach your office. When you are thinking this way, you are using GIS data. G stands for geography, which is places on earth. I stand for information, what is, where, when, and of course, time. S stands for the system, input, storage, analysis, and display of spatial information using software and hardware. Haven't you used a location service like Google Maps? Known as GPS navigation, is a glimpse of GIS. However, the GIS has more data in the form of layers, and layers are built from the actual world. As GIS understands the location and has database attached to the layers, it can help answer very complicated questions quickly. Think about the route you are taking to reach your office. Will the closing down of particular bridge impact the traffic and other emergency services in particular? How many hospitals or fire stations linking that bridge? And now civic bodies can prioritize which road to be repaired first based on the traffic loads. And you know what? The impressive aspect is that GIS have the capability to perform this task for any type of information, not exclusively limited to roads. This technology can effectively handle and assess a variety of data in your everyday task. So, GIS stores data as layers, and layers represent the real world. Layers are made up of spatial and non spatial data. Spatial data is nothing but geometric shapes, points, lines, and polygons. And each of these shapes is tied to its real world location on Earth using latitude and longitude coordinate systems, and that's the real magic behind geographic information systems. And if the data is 3D enabled, you will find a third coordinate, elevation, which is the height above sea level. Things which does not have any dimensions are the points. For example, hospital locations, cases, crime spots, etc. While roads and streets can be represented by the lines. Polygons are for the area to show length and width. Examples are city or country boundary or a farm field, etc. A simple model is shown in two dimensions, but more advanced one can be created in three dimensions to display the height of buildings and other structures. Components of GIS. GIS consists of software, hardware, data, methods, and people using it. Softwares are like all the computer programs, apps used to handle, manipulate, and analyze data, like ArcGIS and QGIS. Hardware range from computer systems to satellites used to capture the GIS data. Data is spatial and non-spatial data that we already talked about. Methods. Methods are techniques, procedure, model, or practices used by GIS user with other components for their projects. and people, from tech specialists and trainers to those who use it to solve problems using GIS technology. I hope now when someone talks about GIS, you will understand what he or she is talking about. Thanks for watching.